It's official. A new Trojan asteroid has been discovered sharing Earth's orbit. Astronomers have confirmed the existence of the second known Earth Trojan asteroid and found that it is much bigger than the first. An Earth Trojan is an asteroid that follows the same path around the Sun as Earth does, either ahead of or behind Earth in its orbit. Called 2020 XL5, the asteroid was discovered by the Pan-STARRS-1 survey telescope in 2020, but astronomers were not sure then whether it was an Earth Trojan. The SOAR telescope operated by Navar Lab in Chile helped confirm that it is an Earth Trojan and found that it is over a kilometer across, almost 3 times bigger than the other Earth Trojan known. Earth has officially been joined in its orbit around the Sun by a new Trojan asteroid. Named 2020 XL5, this chunk of rock is only the second object of its type ever to have been conclusively identified. Its discovery suggests that perhaps Earth Trojans may be more common than we knew, and offers new insights into these mysterious rocks. Like the first Trojan, astronomers predict that 2020 XL5 will hang around for at least 4,000 years before zipping off to parts elsewhere. The discovery of a second Earth Trojan asteroid may enhance our knowledge of the dynamics of this elusive population, scientists write in a new paper. By comparing the orbital nature of the 2 Earth Trojans known so far, we can better understand the mechanisms that allow for their transient stability. Trojan asteroids are asteroids also known as minor planets, that share the orbital path of larger planetary bodies in the Solar System. They can be found in 2 gravitationally stable regions leading and trailing the planet, known as Lagrange points. These are pockets where the gravitational pulls of the planet and the Sun balance perfectly with the centripetal force of any small body in that region to basically hold it in place. Each 2-body system has 5 Lagrange points, as seen in the diagram. There are 5 between Earth and the Moon, and another 5 between Earth and the Sun. The Lagrange points where Trojans can be found are leading L4 and trailing L5 regions. Trojans are well known in the Solar System. Jupiter, naturally, has the most, with well over 11,000 documented, but we've found them hanging out with other planets too. Neptune has 32, Mars has 9, and Uranus has 1. Earth's other Trojan, named 2010 TK7, is a chunk of rock around 300 meters (984 feet) across, hanging about the Earth leading L4 Lagrangian in an oscillating tadpole-shaped orbit known as libration. It's not a permanent fixture, though, eventually, in around 15,000 years, gravitational interactions will kick it out of its current orbit. 2020 XL5 is very similar. It too librates around L4, and will only hang around temporarily, with new observations revealing its orbit in much finer detail. But it's a lot bigger than its companion. New observations using the Southern Astrophysical Research Telescope (SOAR) have allowed astronomers to discern that its diameter is 1,180 meters (3,871 feet). We also now know what type of asteroid it is. SOAR's data allowed us to make a first photometric analysis of the object, revealing that 2020 XL5 is likely a C-type asteroid, with a size larger than 1 kilometer, says astronomer Tony Santana Ros of the University of Alicante in Spain. C-type carbonaceous asteroids are darker in hue because they're rich in carbon. They're also the most numerous asteroids in the Solar System. More than 75% of all Solar System asteroids could be carbonaceous. They're among the oldest objects in the Solar System, with a composition similar to that of the Sun itself. This makes C-type asteroids an attractive target for studying the early Solar System and the formation of the planets, and Earth Trojans potentially even more so. We currently have several space observatories parked in Earth-Sun Lagrange points. Having a C-type asteroid hanging about nearby within reach would be an excellent opportunity. 2020 XL5 might not be it, however. Its orbit takes it nearly as far out as Mars, and crosses Venus's orbital path. but it could show us how to search for other Earth Trojans. Any object orbiting the Lagrangians would be moving around a lot, leaving a very large patch of sky to scour looking for relatively small objects. Having 2 Earth Trojans to study will give astronomers a bigger toolkit for calculating those orbits. In turn, that could help us find a population of potentially hundreds of Earth Trojans, lurking out there in the dark. If we are able to discover more Earth Trojans, and if some of them can have orbits with lower inclinations, they might become cheaper to reach than our Moon, says astronomer Cesar Briceño of the National Science Foundation's NOIR lab. So they might become ideal bases for an advanced exploration of the solar system, or they could even be a source of resources. The team's research has been published in Nature Communications. Create.